Okay, this topic is called factoring out a binomial from a polynomial. From what I can see, as you go through this, it can appear in about three different forms, and they each kind of have their own particular value. Um, this first one is somewhat of an easier variety, but sometimes difficult to notice at first. The key to this type of problem is recognizing that there are a total of three terms in the original problem. Now, the topic name Alex tries to give, in order to be generic, unfortunately can be somewhat a little bit misleading, says factoring out. In this case, you're not really factoring out a binomial as much as recognizing its existence. In this case, the three terms do not share a common factor, so you're not actually factoring something out. You're more of just going to use the fact that the binomial exists as a tool to factor the trinomial. So to get started, what we're going to do to make this problem a little bit simpler is make a substitution. You can pick just about whatever letter you want. I like to use just a big old capital A and say let A equal the x squared plus 8. If you recognize that that x squared plus 8 appears two different places. Squared meaning two factors in the first term and only one factor in the second term, and then does not appear at all in the third term. And if you make that substitution, this problem really becomes quite a bit simpler. A squared minus 5a plus 4. Now, we want college algebra students to be able to recognize that a problem like this can be made simpler with a substitution. You don't actually even have to make the substitution if you don't want to. That's nice. We'll ignore that. Pardon that little glitch in the video. I may edit it out, but if you see it, you see it. At any rate, all I was saying is you don't actually have to make the substitution if you don't want to. Some people find it easier, some people find it confusing. The point here is that it has three terms, and we're going to factor using what amounts to a quadratic factoring method. That is, where you have a factor that appears to the second power, factor that appears to the first power, and then as far as that factor is concerned, a constant term. And so now this just amounts to a quadratic trinomial that we can say, well, that factors a minus 4 and a minus 1. That would, if you check that by multiplication, multiply out to a squared minus 5a plus 4. Now do what we call back substitution and say, well, a was really our x squared plus 8. So we can say this is x squared plus 8 minus 4 times x squared plus 8 minus 1. And now we're able to simplify quite a bit further and say that that is equivalent to x squared plus 4 times x squared plus 7. And so there we have our final answer. That's the simplest we could get this. Notice x squared plus 4 doesn't factor over the real numbers, nor does x squared plus 7 with integers at any rate. So that completes that problem. The next occurrence is actually a little bit more along lines with the name. Still the directions factor completely. So we look at this problem and again identify, well, there are two terms. Notice the difference between those two problems, the one we just did and this one. The first one, there were 3 terms, and that binomial factor did not appear in the third term. So you couldn't do what we're about to do now. Whereas this problem, you see 5x plus 4 is to the second power in the first term, plus 3x, and then that 5x plus 4 is raised to the first power in the second term. So we have it appears in the first term here, second term here. This has the look of a 2-term expression with a common factor. And so what we'd like you to be able to do is get to a point where you can look at this and say, well, 5x plus 4 appears in each term once. So 5x plus 4 is the common factor. That then leaves what remaining from the first term? Well, if you divide away a 5x plus 4 from this first term, you get 5x plus 4 still remaining. Plus, that plus here is the same as that plus here. What's remaining in the second term? A 3x after you divide away the 5x plus 4. So now what you have is this 5x plus 4 as the binomial factor that was divided away from each term written out front. And now we can look at this in combined like terms and say that we have 8x plus 4. Now factor always means factor completely. Now here we're not done. That 8x plus 4 has a common factor of 4 that appears in each term. So we could write that out front of that second group of parentheses, or the more common thing to do is to go ahead and write it all the way out front of our expression. The 4 is pulled all the way out front, multiplied by our 5x plus 4, multiplied by what's remaining if you divide away a 4 from each term, 2x plus 1. And you can check this at each stage with multiplication. And this is actually worth talking about here for just a second. If you look backwards, and I'll attempt to do this without making too big of a mess, but if you look backwards, and I'll say, look at that 4, and if we distribute that 4 to the 2x plus 1, you get your 8x plus 4 with that factor of 5x plus 4 still multiplied out front. And now you got to get creative to say that, well, you could, if you wanted to, split the 8x into a 5x and a 3x and write the 8x plus 4 as an equivalent expression, 5x plus 4 plus 3x. And now, if you want to consider the 5x plus 4 as one term, and I'm talking about this 5x plus 4. If you want to consider that as one term, and then imagine with the distributive property, this 5x plus 4, and distribute it here and here, you would have exactly what we have on the original line. So one of the key things I always talk to people about factoring is that everything you write needs to be equivalent to the line you had above, and you ought to be able to check your work going backwards. And once you get to a point where you can do that for any problem, then you really have a good grasp on what we need you to know about factoring. And I'll do one more, and it's kind of the messiest one. So this one, I say messy. It actually, if you think about it the right way, is simplest. But we'll take a peek at it and talk about it here. So you start with this expression, it says factor completely. And one of the key things to be able to do with really any of the problems we'll look at, or many of the problems we'll look at in this course, is to be able to say how many terms do you have. And with this problem, you have one term minus a second term. Now, it's not at all necessary, and by the way, I didn't do it, but on this previous problem, I'll bounce back to it for just a second. This previous problem, I could have looked at this and thought of this by substitution and said, really, this problem is nothing more than a squared plus 3xa. Where playing the role of a in today's movie is the 5x plus 4. And if you think about what you would do, or what we did to simplify this problem where we factored out that 5x plus 4, you think about this problem, the first and only thing you could do is factor out an a from each of those terms. And that's again, one of those things that some people tend to shy away from, but I think is at least a helpful way of simplifying your thought process. And I'm going to do that, by the way, on this next problem. So when we look at this, I need you to be able to see that this problem, if I imagine this first binomial that appears in each term, is, we'll call that a, and this 5x plus 8, we'll call that b. So if you think about this problem in a simple way, it's like you have 9a to the third b to the third minus 3a to the second b to the fourth. I didn't really write down what my definitions of a and b were for this problem, but I think it's fairly straightforward and obvious. And if you look at that, then our strategy is pretty clear. The only thing you can do is look at those two terms and say, well, they share a common factor of 3a squared b to the third. And how I came up with a squared and b to the third is a to the second is the highest number of factors of a that occurs in each term, and b to the third is the highest number of factors of b, or most number of factors of b that occurs in each term. And the greatest common factor of 9 and 3 is 3. So that's your common factor. There's your subtraction. That common factor is factored out of each of the two terms, so we better have two terms remaining. Once you factor out 3a squared b to the third, what do you have left? Well, we have a 3, and looks like just one factor of a. We divided away all the b's. We don't have any constant factors here in the second term. Since we divided away the 3, we have a 1 remaining. We divided away all of our a's. We divided away 3 of the b's, leaving only 1 remaining. So as far as a and b are concerned, that's really all we can do. Now we can put it back together and say, well, now that equals 3. A was 4x plus 7. That was quantity squared. B was 5x plus 8. That was quantity to the third. And then we have 3a, that's 3 times the quantity 4x plus 7. Got to be careful with your grouping symbols here. Minus, now you're subtracting b, so that means you're subtracting all of b, so we need to be wise about our grouping symbols and write minus the quantity 5x plus 8. And now that still preserves the structure of what we had. And if you notice, inside here, we can clean this up quite a bit further. Little distributive property. So leave the 3 alone out front. 4x plus 7. Quantity squared. 5x plus 8. Quantity to the third power. And now we have 12x minus, or plus rather, 21, distributing the 3. Now distributing the negative sign to the 5x plus 8, that becomes minus 5x minus 8. And now we have some like terms to combine inside this last pair of grouping symbols. And we can say that's equivalent to 3 times 4x plus 7, quantity squared, 5x plus 8, quantity to the third power, and that's 12x minus 5x, so that's 7x plus 21 minus 8, so that's going to be plus 13. And I didn't need to write that grouping symbol that far to the right, so I will erase that and write that right there. And now one last thing, that's our final answer, by the way. One last thing to point out. If you're one of those folks that doesn't like the A's and the B's, then your very first step would be right there. You look at that problem, and eventually, by the way, even if you do like the A's and B's, eventually you don't need to write them. You just look at this and say, well, the common factor that appears in each term is a 3, a 4x plus 7 to the second, and a 5x plus 8 to the third. And then it's just a matter of carefully writing down what remains after you divide that out from each term. So I hope that helps, and I'll see you later.